Hi, it's about to get real on Astro's Electronics Lab today. Greetings, the Astro 30 here with a, well, I wouldn't say fun-filled episode, but probably something that might interest some people. Anyhow, today I'm going to take this creation and transfer it onto here, which is a piece of Vero board. It's 75 by 95 millimeters long and it's JCar catalogue HP 9540. They're about $7. $6.95, something like that. And I've got a bunch of other components over there that I didn't have yesterday when I was doing the breadboarding out, but I've got today. And along with the TL072 IC and IC socket respectively, I've got one of these. It's a 10K 9mm logarithmic miniature pot with 2.5mm lead spacings, which I think will fit through the Vero board there. I'll find out in a minute. These are becoming industry standard now in small electronics, audio electronics. The thing is, they are quite expensive for what they are. They're $4.95 each. And that's only the single gang version. I think the dual gang version is like $5 something. So yeah, they're getting quite expensive. The reason I bought this is because A, I don't have to cut the shaft, and B, it's got a fluted or knurled shaft on there, which will fit a push-on knob just nicely. So what I want to do is I want to open this Vero board up, and I want to actually see if my pot will fit through the holes, because I'd rather not have to drill them out if I don't have to. Okay, so yep, it fits in there just nicely. Okay, so I'm going to, man, it's got quite a bow in it. Don't know if you can see the bow, but man, that's quite bowed. Anyhow, let's move on to showing you the Vero board layout that I've already done this morning, because having a pre-done layout rather than trying to work it out on the board as you go is a hell of a lot easier to work with. Very sexual, you dickhead. Now, this is my Vero board layout. I've used a program which is freely available on the Microsoft store called Drawing Board Pro, and it's absolutely free. And it gives you a rough CAD idea of what the actual final board is going to look like. These little gaps in the tracks here is where you break the tracks. There are some broken up here where you can't see it because the, well, op-amp isn't exactly transparent. It'd be nicer if these components were more transparent. Now you notice this pot down here, trim pot, that's not what actually is being put on there. It's actually a right-angled jobby, but their library is so sparse that's the only thing I could find with the right pin spacing to represent the pot that I'm going to use. Which probably means that this could be actually shortened by one set of holes quite easily. I'll have a look at that in a minute before I cut the board. Now, it's fairly straightforward. The order in which you should build it is break your tracks where necessary first with a 6mm drill bit. Usually works on Vero board quite nicely. Lay out all your link wires. I mean, it is a cluster mess, but it is what it is. And I'm going to use PCB pins for the 9V COM, and in, and the speaker wires I'll probably move down here, actually put two wires there, whatever colour, just for the output, and solder them hard to the board because it's going to be wired directly to the speaker. Now, let's get building. So first off, it was 21 holes up, and the easiest way to do this is to turn it the copper side over and score with a straight edge along the holes, well, one hole above the amount of holes you need. I need 21 holes, so I've scored it on hole number 22. And then just put it on the edge of a desk. And gently snap it off. It's easier to do the scoring on the copper side because it will cut through the copper first. So if you do it the other way, you may run the risk of ripping the copper tracks off on the other side. Right, now I need to work out how wide it needs to be. 17 holes across. Same procedure, but now we're running down the length of a copper track. And I'm using what comes off of that speaker, party speaker, but it doesn't really matter. I'm going to have to redo the finish anyway. Let's see if that's enough now. Put it on the edge of the desk, gently. There we go. And now we have a piece of Vero board. I'm not going to worry too much about that long edge on there, that's fine. We now have a piece of Vero board that I can start assembling with. Now, as I mentioned with the diagram before, you're going to have to break tracks, and it's easier to break the tracks now than it is later. But you've got to be careful because the image that you're looking at that I've drawn, you're looking from the top down. So when you turn it over to break the track, it's going to be mirrored. So you've got to keep a good eye on where you're breaking the tracks, because you can mess it up, and I have done. So I've worked out I need to come in 5 holes from the left hand edge here and 8 holes down. So if I turn it over, that means 5 holes from this edge and 8 down. So the easiest way before breaking anything is to just mark it with a marker where you're going to break. So going 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. That's 1. Indeed. And then that's just for the IC, so I need to come along 3 extra holes, you see. So I can verify that I've got that correct. I'm looking at my diagram. 1, 2, 3, 4, 5 is where it breaks on 5. Track 5, so 1, 2, 3, 4, 5, 6, 7, 8. Track 5, position 8, if you want to call it that. And so all I do is I take my 6mm drill bit, I just gently turn it around. It doesn't take much. 1, 2. You don't want to drill through the board. 3, 4. And you can verify with a multimeter whether or not that those tracks are broken. So now I've got these broken where they need to be. The rest should be easy to work out. And when you're finished, you should have something that looks like that, with all the holes broken where they need to be broken. And I've just verified with a multimeter on continuity checker that they are indeed broken. So now we flip it over and move it back into shot, and then we actually assemble it. Now, I would start first with all the link wires, because they're going to be the most tedious and pain in the arse thing to do. Plus, if you do them first, it allows you to see how the layout is coming along. Now, I haven't worked with Vero board in years, but the smell that it makes when you solder to the copper on this brings back memories. Pleasant ones. That one was being a bit of a bitch to solder. Okay. Just got to try and be mindful that you're not shorting between tracks, or else the circuit will not work and you'll be scratching your head as to wondering why. There was also a mess up in the breaking my hole counting. As I was counting down the board, I seemed to end up with wrong holes. I'm not sure what was going on with that, but I still think the circuit will be able to be assembled the same anyway. And I was slightly out of shot, I do apologise. Be careful when cutting this that you don't put too much pressure on it, or you will rip the track off the board. Ask me how I know. Because I've done it. Okay, I'm not going to take too much footage of the assembly process because it is a lot to edit that way. I will just take bits and pieces along the way. That doesn't look soldered right. Now it is. Oh, I love the smell of Vero board. Oh, it's awesome. Alright. There we go. That's what you should have now if you've assembled things right. Now it's moving on to resistors. Alright, resistors are in. However, yeah, wouldn't you know it, that track is broken in the wrong spot, so that means when I actually come to put this together, I'm going to put the capacitor in that needs to be soldered to there, and I'll just solder the leg of the resistor over to where the capacitor is, so it joins it in. It's the 1K gain resistor that goes to ground via a 1 microfarad capacitor. However, I couldn't find any 1 microfarad capacitors in Jayco. I had to go buy 8.47. Oh well. So speaking of capacitors, I might actually put those in next. Might as well, they're there. And there it is, all built there. Managed to fix my up by joining the end of the 1K resistor, bending it over an angle and hitting it right next to the capacitor lead and soldering them both together. And just cutting the excess off. It's messy, but it is electrically joined. I've already verified that. Now it's time to hook up some power and some test equipment and see if the thing even works, after it took me an hour and a half to assemble it. Suddenly feel like shit all of a sudden for some reason. Anyway, I got everything set up, dummy load, oscillator, oscilloscope. Hook up my battery. Nothing odd on the scope. I'll wind up my control. Ooh, I do actually have an output. It's not very great though. Let me change the battery. I seriously do not know what is going on here, but this is not right. It looks like the frequency is changing more than the volume. With no input signal, it's turned into a oscillator. Alrighty, I found the issue where this capacitor is. I forgot to break the track on this side of the capacitor, so it's basically connecting the input directly to the two emitters of these transistors here. So it's basically connecting the input to the output, and that was the result. Now it appears to be functioning. Alright, let's get back to testing. Seems that most of its gain is right down towards the bottom of the control. So, yeah, righto. Okay. Let's see about there. 0.17 volt, are you kidding me? Well, this is perplexing. The NE5532 seems to function better. And I'm not 100% sure why that is, but okay. Because with the NE5532, even though it's going into distortion, clipping badly, I am getting a more decent output swing. But yeah, it's about halfway, so I need to lower that down. Looks like about 1.4 volt peak to peak before it starts to go funny. So yeah, the NE5532 seems to function a lot better than the blasted TL072, and I don't know why. But okay, we'll go with that. Nice. Where'd that f*** off to? Not bad. Not bad at all. I am kind of pleased with the results. I can turn the soldering iron off now. Turn that down. I'm actually surprised that the TL072 did not perform as it should have. That's really weird. Okay, if the NE5532 proves to work better, then it stays in. So, yeah. I'll have to update my CAD drawing with that extra broken track there because I forgot to do it in the first place. Anyway, tell me what you think below. I'm going to close this video out here. The plans for the circuit layout and the circuit diagram are on my Patreon. I'll put a link in the description. Anyway, this is Astro30 saying, if you enjoyed this video, please remember to rate, comment and subscribe down below, and you can always follow me on Facebook, and you can always become a Patreon for as little as $1 a month. Links are in the description as usual. Anyway, this is the Astro30 saying, see ya, have a great day.